Hello everyone, myself Dsp Bhale. Our group number is 13 and our subject is digital signal processing. My group members are Nazneen Mulani and Ankita Jadhav. Today I am going to explain the FR low pass filter using Simulink on MATLAB. So we have take model based design using Simulink, which is ninth order FR low pass filter using windowing Hamming technique, where Fs is equal to 2000 Hz and Fc is equal to 100 Hz. So here is the introduction part about low pass filter. A low pass filter is one which suppresses the high frequency components of a spectrum while passing the low frequencies within a specified range. In digital signal processing, an FIR is a filter whose impulse response is of finite period. As a result of it settles to zero to infinite time. The impulse response of an nth order discrete time FR filter takes precisely n plus 1 samples before it then settles to zero. FR filters are most popular kind of filters executed in software, and this next part I will hand over to the Nazneen Mulani.
So this is the Simulink of FIR low pass filter by using windowing Hamming technique. Discrete sine wave is taken as a input from where we can change amplitude as well as the frequency of the signal. The output of the discrete sine wave is given as input to the filter design. As per our problem statement, we are using ninth order FIR low pass filter by using windowing Hamming technique by giving sampling frequency is equals to 2 kHz and cutoff frequency is equals to 100 Hz. The output of a filter design is given to the scope from where we can check the output of the whole system, and FFT, that is fast Fourier transform, is also attached at the output so that we can check the frequency spectrum as well. So further slide will hand over to the Ankita Jadhav. Thank you so much.
So here is the output of the simulation. The second figure shows the output of the FIR low pass filter, which is a frequency response. Here x-axis indicates the frequency and y-axis indicates the gain in dBm. This output is given to the FFT. FFT can convert the frequency response to the time domain signal. And the first figure, sine wave, is indicates the output of the FFT, where amplitude and frequency can be adjusted. Here x-axis indicates the time and y-axis indicates the amplitude. Now the last part is conclusion. The FIR filter is non-recursive filter in that the output from the filter is computed by using the current and previous inputs. It does not uses the previous values of the output. So here is no feedback. The design of a FIR filter is best identifying the impulse transfer function that satisfies the requirement of the filter specifications.